for 10.5, it's on exponential functions. So first let's review what an exponent is. An exponent is a number that shows repeated multiplication. So an example of that would be 2 to the 5th. I'm doing 2 times 2 times 2 times 2, where 2 is repeating 5 times. And a function is a relationship that has one output for every input. Okay, powers of 2. So powers of 2, that is 2, 2 to, and then my next one would be 2 times 2, which is 4, then 8, 16, 32, and I keep going on. Powers of 10, those are going to be 10, 100, 1,000, 10,000, and I keep going on. Okay? So an exponential function is a function that can be described by an equation in the form y equals ax, where a has to be positive and cannot equal 1. So what does this look like? So let's make a table, and let's do when a is 2. So I have my x's, I have my y's. Let's just do 0, 1, and 1, 2, and 3. So when I plug in 0, 2 to the 0 is 1. When I plug in 1, 2 to the 1 is still 2. Plug in 2, 2 squared is going to be 4. And 2 to the third is going to be 8. So what does this look like? So as my x's are increasing by 1, I'm adding 1, adding 1, adding 1. What's happening here? I'm adding 1, I'm then adding 2, I'm adding 4. What do you think is going to happen next? Well, if I had 4, it's going to be adding 8, which is 16. Every time it is doubling from before. So 2, I'm doubling that. I'm doubling the 4 times 2 would be giving me 8. 8 times 2 gives me 16. Every time I'm multiplying it by 2. So as x increases by 1, my y is increasing by a multiple. In this case, we are doubling my y value from the previous one. So in an exponential function, you are not going to have a steady rate of change. I have 1 over 1. I have 1 over 1. I then have 2 over 1. I have 4 over 1. I have 8 over 1. It's going to continue increasing as you get bigger and bigger. All right, so let's look at example 1. 3 to the x. So let's make a table. X, y, 0, 1, 2, 3. 3 to the 0 is going to equal 1. 3 to the 1 is going to equal 3. What do you think 3 to the third is going to be? Okay. Let's look at if it's a fraction. So when I have to the 1, this is 1/2. When I have it squared, I'm squaring not only the 1, but I'm also squaring the 2. So that is 1 over 4. Here I'm cubing, 1/2. So that's 1 cubed, which is 1, and 2 cubed, which is 2 times 2 times 2, which would be 8. So what happens when it is a fraction, when a is a fraction? That it is getting smaller and smaller and smaller. So it's going 1/2 to 1/4, 1/8, 1/16. So in this case, it's cutting it in half. Okay? All right, so what happens when we add or subtract values? So what do you think is going to happen when I add this 4? My y value increasing by 4. So in other words, I'm shifting it up 4. So if I subtract a negative 25, I'm decreasing my y value by 25. So I'm shifting it down 25. Okay? So your initial value, which is your y-intercept, that is the point where the function crosses the y-axis. This would be the value you get when you plug in 0 for x. So in example 3, my y-intercept is going to be the 4. And in example, it is going to be 7 because I have y equals 3 times 2 to the 1, 2 to the 0, plus 4. Remember, anything to the 0 power is 1. So this is 3 times 1 plus 4. So 3 plus 4 gives me 7. So my initial value is going to be at 7, and I'm going to increase from there. The other one, when I have 2 times 5 to the 0 minus 25, 2 times 1 minus 25, so 2 minus 25. So my initial value is going to be at negative 23. And from there, I am going to increase. So my graph would look like this at 7, and it's going to go like this. And this one at negative 23, and it's going to go like this. Okay? So how can we identify an exponential function? So looking at it, the exponent contains your x. If you're looking at a graph, it is a curved line to start with. What other types of functions do we know? So up until this point, we've only talked about one other type, and that is linear. So linears have straight lines. Exponentials is is when my y is increasing faster than my x. So it is going to look like this. All right, so let's look at a table and see if we can identify. So to identify if I have an exponential, I need to see my rate of change. So here I'm adding 2, adding 2. What am I doing from 1 to 9? I'm using multiplication. So I times it by 9. To go from 9 to 81, I'm timesing by 9. Sorry, not timesing. We want to look at adding. So I'm adding 8 here. I'm adding 72 here. So notice that these two rates of change are 8 over 2 versus 72 over 2. They are not the same rate of change. So that means I have an exponential number. So what is happening to go from 1 to 9 to 81? So when I'm looking at 1 to 9 to 81, well, how do I multiply? Remember, exponentials are using exponents. So what am I multiplying by to get something to squared? So a squared has to equal 9. Well, what do we know that squares to 9? Or in other words, the square root of 9. So when I square root, I'm undoing that squared. So I get a is equal to 3. So my equation is going to be y equals 3 to the x. Okay? Let's look at example 6. So I'm adding 1, adding 1, adding 10, adding 10. Is this exponential or linear? This is a linear function. With a rate of change of 10 over 1 for all rates of change. So my slope is going to be 10. And if I took 10 away to get me back at the intercept, I have a value of 0. So y equals 10x is my equation. Do you notice the two differences of these two equations? X is in the exponent here, x is in the base part here.